Okay, so for this, I will now show that this is the second lecture of elasticity, and I'm making this YouTube video. If you go to Canvas, you can download the class notes, and you can fill that out as you go along. We are continuing our discussion of about elasticities, and we've had a little bit of a discussion already, so this is just continuing that discussion. If you look at there's four types of elasticities we talk about. There's a price elasticity of demand, price elasticity of supply, the cross price elasticity of demand, the income elasticity of demand. What we're looking at is if you get a 1%, it scales down for the demand to supply. If you get a 1% change in the price, what is a percent change in quantity? For the cross price elasticity, what happens if you have a 1% change in the price of good A? What is a percent change in the quantity of good B? Income elasticity, that's the substitution effect. The income elasticity of demand, that's if you have a 1% change of income, what is a percent change of quantity demanded? And there's a couple of things we can look at. If you pull out your notes, it'll look something like this. And I'm going to write down the formulas here the best I can. So elasticity is equal to the percent change of quantity demanded over the percent. The delta is the Greek sign for change of price. And elasticity of supply, there should be two P's in there. Elasticity equals, again, it's a percent change of quantity, and you put an S down here, supplied over the percent change of price. And the cross price elasticity of demand, that's E of B over A. That just shows that you have two different types of goods or services there, equals the percent change, that's horrible, B, of quantity and then demanded of B changes with the percent change of the price, that's a horrible P, sorry, the price of good A. And income elasticity of demand, E, and then you put an I down here because you're looking at income, equals a percent change of quantity demanded over percent change of income. Okay, so that's how those work. And I'll go ahead and clear all my drawings. You don't have to look at those anymore. And in this, we also talked about a couple of different formulas that we could use. There is the starting point formula, and if we use that for quantity or supply, it's the same thing. P2 minus P1 divided by P1, the midpoint, and you do the same thing for the quantity. The midpoint formula is P2 minus P1 divided by the average of those two. And these give you algebraic approximations of the rate of changes. Ultimately, we're looking at the percent change of quantity over the percent change of price. And these will give you something that's pretty good to get there. The textbook that we use talks about how you multiply the numerator, denominator by 100, but you'll recall that 100 divided by 100 is still 1. You effectively multiplying it by 1. Ultimately what they're doing is they're changing it from percentage to a proportion to a percentage. When you move the decimal over 2 times, you slap a little percent sign, that's the same thing. When you use a midpoint formula, remember it's going A to B is not the same as going from B to A. It was a starting point formula, excuse me. The midpoint formula, it'll be the same thing. And these will be a little bit easier to compute and when you get to Econ 380 because you'll get to use calculus, which will give you a little bit more precise. But this is fundamental class, so we're just doing algebra. Okay, there's our discussion about the formulas. The signs are important. If you're looking at the cross price elasticity of demand and supply, if you look at different textbooks, sometimes you'll see the absolute value, sometimes you'll see a negative sign. Those things you pretty much ignore. So demand and supply, let me go to annotate again. Let me drop this down. Ignore. You know what? I'll just do this. Ignore sign, use absolute value. That's what I would put in here if I were filling out these notes. Okay, I'm going to actually move this down just a little bit so we can see. Now, what happens if you have the cross price elasticity of demand? If it's positive, they are substitutes with each other. And if they're negative, they're complements. And let's think about what that means. With cross price elasticity of demand, we're looking at the percent change of the quantity compared to the percent change of price of the other good. So if you have two goods and the price of one good goes up, you would expect the quantity demanded to go down. And if they're complements, the other good would go down as well. If they're substitutes, as the quantity demanded and one goes down, the other one would go down. So with these, that's, I mean, think about it algebraic, I think that'll make more sense. If they're zero, if you change the price of one, the quantity demanded of the other doesn't change at all, then they're not related to each other. And the further you go away from zero, so for substitutes, further you go away from zero positive, that means they're much stronger. They're much stronger substitute, because you change the price of one, they'll buy even more of that of the other one, or less of it if you if you raise the price. With negative, or with the complementary goods where they're negative, the further away from zero you go, the stronger the negative, the stronger the complement they are. And so if they're positive, they're substitutes. Let's come back here and we go to annotate again. Text. Positive, they are substitutes. Negative, complements. Zero, not related at all. So you might want to put something like that in your notes here, however you put that in there. Okay, we'll go back to this. So then what happens if you have the income elasticity of demand? If they're positive, it's a normal good. That means you're talking about there's a direct relationship between income. If income goes up, you demand more of that good. Or income goes down, you demand less of it. The two negatives will make a positive. Therefore, it's a negative. It's a normal good if it's positive. If it's negative, it's an inferior good. So if income goes up, you buy less of it, and then that's an inferior good. If income goes down, you buy more of it. That's an inferior good. We're looking at the income effect. So positive means that it's a normal good. So positive. We go back to annotate. Positive, normal good. Negative, inferior good. And if you get those two mixed up, what I encourage you to do, hopefully you have the right formulas down. Look at the formulas and think about what happens when you change the quantity or the price and what that does to the sign of the entire elasticity. And I think that should probably give you enough to realize which one is which, as long as the formula is correct there. Okay, so there's our little discussion on what those formulas are. Let's look at some ones where we practice. Oops, let me stop doing that. Oh yeah, let me show you this. What happens if you have, so the elasticity of demand and supply, we're looking at how responsive the quantity is supplied is to a change in the price. I really like these pictures on here. because it shows, I think it gives a pretty clear explanation of what's going on. If the elasticity is positive, or excuse me, greater than 1, the absolute value of the elasticity is greater than 1, it's elastic. And let's look at what happens if the supply goes from S to S1. There's a huge change in quantity and a small change in price. If you're shifting the demand curve, there's a huge change in quantity, a small change in price, either way. I mean, this shows S and S1, and you could go one way or to the other. But really what I wanted to show you is if it's elastic, that means the amount that are either supplied or demanded is extremely responsive to the price. If it's unit elastic, that's the bottom one, if elasticity equals 1, that means there's a corresponding change. The proportion change of quantity changes with the change in price, if you either for supply or demand. The inelastic means elasticity has a value of less than 1, which means that you have to change the price by a whole lot to get a very small change in the quantity. And this applies for both demand and supply. And when you're looking at, you can move the supply curve either way or demand curve either way. And you can see that there's a huge change in price compared to a small change in quantity. So let's think about that as we move on to the next slide. We have this one where we circle elastic, unit elastic, or inelastic below. And so, I mean, if you look at the previous note, you'll see that all of these, first ones right here, all of these are elastic. And then where you have a value of 1, that's unit elastic. So a single change, one percent change in quantity corresponds to 1% change in price, and vice versa. Inelastic means that there's a much larger percent change in the price compared to the percent change in quantity. And so anyway, that's how you fill out this one. There, I'm going to clear that. Or anyways, that looks a little bit nicer, highlight. Let's compute the total revenue for these. You compute the total revenue is equal to price times quantity. And for annotating, I'm going to use some text because that'll look nicer. 0 times, if you sell 0 goods at $100 a pop, you'll get 0 in return. 10 for 900. Notice that's a huge change in the percent of quantity with a very small change in the percent of price. But you get 900 right there, right here. And so, and with a huge change of the quantity, small proportion change in the price, that's very elastic. With this one, 2, that's 1, 6 plus 2 zeros, 1600. This one is 2100. And we're still looking at the elastic range. Right here, we're looking at 2 zeros. And at 50 units for $50, that's 2,500. And this one is 2,400. 70 times 30 is 2,100. 80 times 20 is 1,600. 90 times, that's 900. And again, if you sell 100 units at 0, that is 0. And what's interesting here is everything from A to E is elastic. You see a much larger change. And if you were to look at the marginal revenues, how much revenue you get with each one of these, it's greater when the elasticity is greater. And so if you want to increase, and if the elasticity of demand is pretty high, and you want to increase your revenue, you increase your quantity, you can lower your price to the market clearing price, and that'll help you out, increase your revenue even more. If you have a very low elasticity of demand, you can increase your revenue by reducing the quantity, increasing the price. Okay, I'll go ahead and go on to the next slide with this one. There's the values. Next one, complete the table below for elasticity of demand for small sodas and total revenue. Use a midpoint formula to compute the elasticity of demand. Okay, so let's go ahead and start working on these. So if you go from 125 to $1, that's a price, and then that's 410 to 470. So I'll go ahead and start computing each of these individually. Looking at the price, you go from $1.25 minus $1, that's a quarter, so 0.25 in the numerator. The denominator, you take the average of 1.25 plus 1 divided by 2. So that's going to be 1.125. So the middle point of those two. So 0.25 divided by 1.25, I put that in my calculator. I get 0.222. And I'll just write 0.2 with a bar over it because it's that number going on to perpetuity. And then how about this next one right here, 150 minus 125 divided by the average of those two. That's again 25 cents in the numerator. And then that's going to be 1.375 in the denominator. If I calculate that out, that comes out to, let's see, 0.182 with a bar over, or 18.2%. Oh, I better put the text in here. 175 minus 150, that's 25 cents in the numerator again. You take the difference between those two, and that's going to be 1.625. Divide those two out. That comes out to 0.154 or 15.4%. And then you do the same thing here, $2 minus $1.75, that's 25 cents the numerator. And that's going to be 1.875 in the denominator. Take those two, that'll be 13%, 0.13. Oh. Anyways, a bunch of threes. Let's do the same thing for quantity. So 410 minus 470, that's 60 in the numerator. Half of that is 30. If you find the midpoint, so 410 plus 30 is 440. So 60 divided by, that's a negative 60. Negative 60 divided by 440 is, let's see, it's going to be negative 0.136. Here we have 350 minus 410, that's negative 60. And take the average of the two, that's 380. So that's going to be negative 0.158 or negative 15.8%. 280 minus 350, that's 70. And the numerator, so add 35 or subtract to the bottom or add it to the top one. That's going to be 315. So negative 70 divided by 315 comes out to negative 0.222. And this last one, 240 minus 280 is negative 40. So the difference is the 2 divided by 260. So negative 40 divided by 260 is negative 0.154. Okay, and now if we were to do a little bit of math in here, let's see, 22.222% divided by 13.6% is, looks like I came to 0.61. And right here, 8.182 divided by negative 158. Let's see if I did this right, negative 0.87. And let's see, 15.4% divided by negative 22.2%. Comes out to negative 1.44, I think. Okay, so now we're starting to get into elastic. And let's see, this one, 13.3% divided by negative 15.4%, negative 1.15. Anyways, those are the elasticity of demand we had for these sodas. So here we see a larger percent change of the price compared to the percent change in quantity. Here we see a larger percent change in the quantity compared to the percent change in price. You want to maximize the revenue, you're probably somewhere between those two. Let's go ahead and compute the revenue. 470 times $1, that's real easy. 470. 125 times 410, that comes out to 512. $1.50 times 350, probably should be able to do this in my head. Let's see, comes out to 525. 175 times 280 comes out to 490, and $2 times 240, well, that's 480. That should be 480. Just, there we go. So anyways, those are all the answers for that example that worked through. And we could see the maximum revenue is probably a little bit north of a price of $1.50 and somewhere between those two. And we could pull out our fancy algebra skills and actually probably, with enough practice, come up with the sweet spot there to maximize the revenue. Anyway, so there's price quantity. We just calculated the elasticity of demand for these sodas and computed the revenue that we get from that. Okay, clear these out. Let's move on to the next slide. Let's complete the table below for elasticity of supply. A couple things we could think about. So there's the formula, E equals percent change of Q over the percent change of P. And so if we want to compute the elasticity here, so what happens if you have a percent change in these corresponding percent changes? What is the elasticity going to be? We have 15% divided by 35. I put that in the calculator. That comes out to 0.43. And so that's inelastic. And right here, this one's going to be easy. 12 divided by 9. That is 1.33. So here it's an elastic value. How do we compute these other ones? So if we know that the elasticity of demand is 3, and you increased the quantity demanded by 150%, what is the percent change of price? Well, if we know this, use this formula, that can tell us. And let's do a little bit of algebraic manipulation before we get there. So if E is equal to Q divided by price, and we want to solve for price, the next thing we can do is multiply both sides by price. So we get PE is equal to Q, and then we divide each side by E. That gives us was P is equal to Q divided by E. And so we can use that formula because we have two knowns, one unknown, and that will tell us what these are. And so if the price is 150, the E is 3. Oh, that should be easy. That would be a 50% change. That one we can do in our head easily enough. A 50% change in the price would correspond with 150% increase in quantity with an elasticity of 3. And if you move these signs around, however, they'll come out to the same thing. So what happens if we have elasticity of demand of 0.05 and a percent change of quantity, you increase by 8%? What is the proportional percent change of price? Well, we'll use this formula we just came up with. P is equal to 8% divided by 0.05, and that gets us 160%, or 1.6. And we can do the same type of thought process that we did up here to come up with what is going to be, if we know what the percent change of price is, the elasticity of demand is 2, what kind of a change in quantity can we expect? Well, if E is equal to Q divided by P, and we want to isolate Q on one side, we multiply both sides by P, it'll cancel out of the QP side. So we have PE is equal to Q. So all we got to do is multiply 6% times 2, and that will give us 12%. And then right here, multiply 6% times 0.5. I think, yeah, that one's 3%. Or multiply it, we basically cut it in half. And that tells us what kind of a proportion change we should expect if we know what the elasticity of demand is and a percent change in price. Okay. Let me see how it stopped going to annotate. There we go. So look, this brings us to, we're looking at the cross price elasticity of demand and income elasticity of demand. So remember, with in the published articles, you'll see price. The sign for price elasticity of demand and supply, you'll usually see the absolute value. You won't see like a -2 or whatever. I mean, you might, but just remember, it comes to the same thing. The cross price elasticity of demand, if it's positive, they're substitute goods. If they're negative, they're complementary goods. If it's 0, they're not related to each other at all. Income elasticity of demand, if they're positive, and then it's a normal good. The income elasticity of demand, if it's negative, we would see it as an inferior good. And I've got a couple of examples here. Let's say truck sales decreased about 2% since the last major gasoline price hike of 5%. What is the cross price elasticity of demand? Are trucks and gasoline substitutes, complements, or unrelated good? And I kept the formula up here, which should help a little bit as we do this. So let's think about this. Elasticity equals, and then we have a percent change, truck sales decreased by 2%. So that's a -2% with a gasoline price hike of 5%. Okay, so with that, we have -2% divided by 5%. If we do the math, we get -0.4. And if that's a negative value, and then they are, let me draw, there we go. With a negative value to complements, how do I, there we go. They're complements. I'll just circle that. Okay, the store manager drops the price of vanilla ice cream by 10%, and notice a corresponding decrease in the sale for chocolate ice cream by 8%. What is the cross price elasticity of demand? Is chocolate and vanilla ice cream, are chocolate vanilla ice cream complement, substitutes, or unrelated goods? So E equals the percent change of quantity. They decreased this 8%, -8%, and they dropped the price. The price is of vanilla ice cream is -10%. That should be percent. And if we do the math, 8% divided by -8% divided by -10%, the two negatives cancel each other out. Percentages do too for all practical matter. So 0.8 with a value of 0.8. Is that positive or negative? Well, that's a positive value. And if they're positive, we can expect them to be substitutes. So vanilla ice cream and chocolate ice cream in this scenario are substitutes to each other. And the last one, the department store manager raises the price of their best-selling purses by 5%. Number of men's cross-training shoes sold does not change. What is the cross-price elasticity of demand? So let's put that in there. E equals, and then the percent change of quantity, 0% change of the running shoes, and the positive 5% or the purses, and that equals 0. So with a cross price elasticity of 0, that means they are, there we go, unrelated to each other. You can change the price of purchase all you want, and that will not change how many men's shoes are sold in this particular department store. Oh, then you turn this annotation off, clear all drawings. And let's go back to this one. If it's a normal good, it'll be positive for income elasticity to demand. That means as income goes up, the quantity demanded goes up. If income goes down, and then the amount that's purchased also goes down. For inferior goods, there's an inverse relationship. So if income increases, quantity goes down. If income decreases, the quantity goes up. So that will result in negative value for inferior good. So that's the income effect that we can measure out with the income elasticity of demand. And for this one, I came up with a little bit of an example. I made up a town called Utopia. And let's say their GDP increases from 50,000 a year to 55,000. As a result, demand for scooters goes up from 1,000 to 1,200. Number of cab rides also saw a dip from 500 to 400. Using the midpoint formula, let's compute the income elasticity of demand and indicate if the good is normal or inferior. And we could think about this, and we'll get our answer depending on how, with our math. But if it's a normal good with an increase in income, you would expect a corresponding increase in purchases. So the income goes up. So this is what we ought to expect. If the income goes up and the quantity demanded of cab ride goes down, that's an inferior good. I mean, we already know that by definition, but let's do this mathematically. So if we have, let's look at the numerator. Well, actually, let's look at income first. We have a percent change of income. So 55,000 minus 5,000 is 5,000. I'll just write that over here. You know what? I'm going to do text. It'll look nicer. 5,000 in the numerator. And we divide that by, let's see, 55,000. Oh, the midpoint formula, that would be halfway between 50,000 and 55,000 is 52,500. And so that is a change of income. And I'm going to put that in my calculator. And let's see, that is 0.095. And the nice thing about this is that that's for both of these, or that is 9.5%. So I'll just do 9.5%. And then let's look at the percent change of quantity. So here we have 1,200 minus 1,000, that's 200, divided by the average of the two, that's 1,100. So I'll do the math over here to the side. 200 divided by 1,100 equals 18.2%. 18.2%. And if we do the math here, so the percent, 18.2% divided by 9.5, that's about 2. Plug into my calculator, 1.91. And that's a positive value. So if it's a positive value, we know it's a normal good. And let's look at the cab rides. We already have the percent change of income. What happens using the midpoint formula? We have 400 minus 500. That's negative 100 divided by the average of those two. That's 450. And if we do the math on this, that's negative 0.222, or I guess in this case we'd have negative 22.2%. Comes to the same thing. And so we take the ratio of negative 22.2% divided by 9.5, we get negative 2.3. And that's a negative value until it's an inferior good. Okay, that means we did the math right. And that's, oh. We cleared these annotations. Okay, so that brings us to the end of the slides. But let me show you a couple more things that I think you might find interesting. Let's work through 9 more problems. I think I can scrounge up over here. Okay, the price of season tickets to the performing arts decreases by 3%. As a result, the quantity demanded increases by 6%. The price elasticity of demand for season tickets is, now you'll recall the formula for the price elasticity of demand is the percent change of quantity divided by the percent change of price. And so let me go back to, so 6% divided by negative 3% comes to a value of negative 2. This next question, the price elasticity for a product is negative 2.5. Then a price cut from $2 to $1.80 will blank the quantity demanded by about blank. How do we figure that out? So the price elasticity of demand, let me go so I can annotate again. If E equals Q over P, and we have negative 2.5 is equal to $2 to $1.80. So that's a 20-cent decrease. A negative 0.2, that's a difference, divided by 2 that's a negative 0.1. So it's a 10% change. So Q divided by negative 0.1. Or a 10% change. And if we multiply both sides by negative 0.1 times negative 2.5 equals Q, the two negatives cancel each other out. And so we get a positive 0.25 equals Q. And that's a positive, so it's an increase. So it will increase the quantity demanded by about 25% because 0.25 is equal to 25%. And there's the answer for the second question on the quiz. Let's look at the next question on the quiz. Use the data in the table below to answer the following questions. The price elasticity of demand based on the midpoint formula when the price increases from $14 to $16. So we're looking at these two with the corresponding of those two. And so what we have, the Q is 20 minus 24 divided by, then I'll just do average of 20 and 24, which is equal to negative 4 divided by 22. Put that in my calculator. That is negative 0.18888, a bunch of 8s after that. Okay, so that's the numerator. Let's look at the price. So you're going from 16 to 24. 16 minus 24. Divided by the average of 16, 24. Oh, 14. Let's see, what did I do? No, I did this wrong. 14 to 16. So we're going from, so 16 minus 14 divided by the average of 16 and 14. That's equal to 2 divided by 15. Is 0.1, and then a bunch of threes. If you take that ratio of negative 18.8% divided by 13.3, negative 18.8, whatever, however you want to round it, divided by 13.3%, put that in my calculator. Yeah, I came up with negative 1.3636. Oh, that should be. And it looks like the closest answer to that is negative 1.37. So they might have rounded something a little bit different somewhere in there. Anyways, so that's the answer for that one and how we solve that one. Let's go to number 4. The cross price elasticity demand between X and Y is 2. It can be inferred that they are substitutes. So as the quantity of one is positive and the price of the other would have to be positive for it to be, the whole thing be positive, or if they're both negative. So and you could think about it. So if they're both positive, they're substitutes. Let's look at this next one. If we expect the cross price elasticity demand between dress shirts and ties to be blank, indicating that they are blank. I've always seen, it's common to see dress shirts and ties together. So let's just go ahead and assume they're complements. And that would get rid of, well, secondary good, that's not really something. Substitutes, that might be, well, it can't be negative and substitutes. It's negative and complements. It would be positive and substitutes. And so that's why that one's wrong. But if you think about it this way, if the price of ties goes up, the quantity demanded of ties will go down. And if the two of them are complements, you would expect the quantity of shirts to go down as well. And if the price of shirts goes up, the quantity of shirts will go down, which means the quantity of ties would go down. The price of ties goes down, we'd expect the quantity of ties to go up, which means the quantity of shirts would go up if they're complements. If the price of shirts goes down, the quantity of shirts would go up and the quantity of ties would go up as well because they're complements. Anyways, there's a few ways how you can look at it, but there's the right answer. It would be negative and they are complements to each other. Okay, so that's question number 5. Let's look at number 6. Cross price elasticity of demand between X and Y is negative 1.2. That means that they are complements. And I mean, using the same example we just talked about with the shirts and the ties, anytime the cross price elasticity is negative, they're complements. If they're positive, they're substitutes. If the value is 0, then they are unrelated. Inferior has more to do with the price elasticity of income. And income's not part of that if it's either an inferior or normal good. That's question number 6. Question number 7, a negative income elasticity of demand indicates the product is an inferior good. So if it's an income elasticity of demand, it will either be an inferior or normal good. I mean, that's how we can cancel. We know that it's not a, go back, annotating again. It's not a complementary good. It's not a substitute good. that has to do with the cross price elasticity. So if it's negative, I mean, the price of one goes up, the quantity is, if its price is positive for one, the quantity demanded will be negative. That means if income goes up, they buy less of it. And that's what the answer for this one. If they're both matching, it would be a normal good, but that's not the case. Okay, so there's that answer. Let's go to number 8. The relationship between the consumer's monthly income and monthly consumption of 4 products, Y to Z, is shown below. Which product listed is an example of an inferior good? An inferior good means as income goes up, the quantity demanded goes down. As income goes down, the quantity demanded goes up. So if we want to look at it, we can look at it either way. And so if income goes from 4,000 to 5,000, there's an inferior good, it would go down. With W, we see it goes 45 to 60, so it's not that. With X, it goes from 90 to 180. If it doubles with the increase, nope, that's not it either. If it goes from 20 to 10 with the increase in income, that's correct. If it goes from 0 to 15, that's an increase. With a corresponding increase in income, it can't be that. So therefore, oops, that's a bad X. So therefore, the answer is Y. And you could look at it the other way. If it goes from 5,000, drops to 4,000, here it goes 60 to 45, that's a decrease. 180 to 90, that's a decrease. 20 to 10, that would be an increase. 15 to 0, well, that's a decrease. So if either way you go at it with an increase or a decrease, you'll notice that, I mean, you can see how the corresponding changes. And either way, that's the inferior good is good Y in that example. And that brings us to the very last question on the quiz. The price elasticity of supply for a product will be 2 and then let's see what happens if let's make a little table. Go back to annotating. So recall that the elasticity of supply is the quantity supplied divided by the price. And so with the first one, we have a decrease in quantity is negative 0.2 divided by positive 1%. Oh, let's do percent, I guess, if you want to be a little more accurate. And if I decrease, and so that gives us elasticity of 0.2. That's for the first one. And let's look at this next one right here. We're looking at a decrease in 1% minus 1% divided by a negative 2%. And that's equal to, 1/2. 0.5. And that's not elasticity of 2. And let's look at this one. A 1% price 2% minus 2% divided by negative 1%, and that equals to 2. And that's the right answer. But just for giggles, let's do this last one as well. At 2, okay. We're looking at how much the quantity, 2% negative, 2% divided by negative 2%, and that's equal to 1. So we just calculated each of the elasticities, and it's asking which one, the price elasticity of supply for a product will be 2. Which one is that? That's this one right here, the third one, when we do the math. And so, well, anyways, I hope that made sense. If any of those didn't make sense, let me know. We can set up a time, or we can meet during office hours, and I'll be happy to, we could talk about any of those with a little more detail. Thank you for enduring this lecture through YouTube. Please let me know if you have any questions about today's lecture. Send me an email and I'll either correspond or we'll set. Anyways, hope you have a great day.